instantaneous slope, or the derivative. If we have some unknown function, and we call it y of x, we determined that if we wanted to know the average slope between 2 points, x and x plus delta x, this point here was going to be y of x, and this point here would be y of x plus delta x. So once I know x and delta x, I can plug them into this unknown function or given function and determine this height. I'll be able to determine the average slope, delta y over delta x, as y of x plus delta x minus y of x all over delta x. We got this formula from the average slope. Now, what we're trying to do here is we are going to make delta x approach 0. So everything else stays the same, but all we're going to do here is we're going to define an instantaneous slope. The slope that is right, instead of being between 2 points, that is at this point. Exactly at this point right here, with delta x equaling to 0, going towards 0. So the formula becomes that delta y over delta x for instantaneous, let's call it instantaneous, instance is going to be equal to the limit as delta x goes towards 0 of this function right here. And last but not least, this is no longer called delta y over delta x because these deltas are so small because they are literally going to 0. We have a special name for it, and we call it dy over dx. And that's exactly what it is. It still says that it's delta y over delta x, but it's so small, it's infinitesimally small because delta x is going to 0 that we take dy by dy by dx, and d is supposed to represent that instantaneous small distance, and that is instantaneous rate of change.